ratios, and this is usually a variation of the formula you learn in school. Pi equals C over 2R. And I'm just going to speed up for you this real quickly. When you're graphing pi, it's usually with around the unit circle, which is just a circle with a radius of 1. And at every point, say cosine would be how far the x goes at any point on the circle. So for cosine pi, x equals 1 and sine equals 0 because sine is y, x is cosine. X goes over 1 and it raises up to 0. And it goes on forever. And this is just another graph that explains it easily. Like over here, on the length around the circumference is measured in radians. And here's 1 radian, which is 1, which is the same length as from the center to the outside. So, yeah, all this drudgery goes over to Euler's formula, which is e to the I, usually theta, but here we're using it for pi. So e to the I pi is equal to cosine pi plus sine pi. And the e comes from financing. This is said to be one of the most beautiful and profound formulas in all of mathematics because the E comes from financing to find continuous compounding interest, the I from engineering to find the roots of various polynomials around the formula. And pi from the unit circle, and cosine and sine from trigonometry. So all of this, if you substitute 4 pi, cosine of pi, and yeah, just go. Cosine of pi is equal to -1 because the cosine will just go of pi is halfway around the unit circle. So it'd be -1 and sine of pi goes up 0. So if you rearrange this, you get e to the pi plus 1 equals 0. And that's said to be one of the most profound unit formulas just because it unifies all these basic fields that usually have absolutely nothing to do with each other. And if you graph it, I forgot to clean pictures of the graph, but it comes out to some very interesting just designs on a 3-dimensional chart. But I personally would have thought it would have been even better if this -1 was actually a 1, so that it would imply unity, like perfect unity among all fields. And then, so this is where I'm going with this. I'm saying that pi is not exactly the best number we should be focusing on, rather than tau, which is essentially 2 pi. With that, it says we can rearrange the formula saying c is equal, or pi is equal to c over 2. It becomes tau is equal to c over r. Instead of being a ratio between the circumference and the diameter, it's the ratio between the circumference and the radius. Sorry. And so tau is just equal to 2 pi. And here we are again. Essentially, you'll notice that these are all the same, except right here, instead of pi over 2, it's pi over 4. So that one turn around the unit circle is 1/4 tau, rather than 1/2 pi. And one whole revolution around the circle is equal to tau. So it becomes more intuitive saying that 1/2 turn is 1/4 turn, or 1/4 turn is 1/4 tau, 1/2 turn is 1/2 tau, 3/4 turn is 3/4 tau, and so on. Rather than pi, where the whole revolution is 2 pi. A refutation is like just some formulas become messier. Like for area pi r squared, you would have to rearrange tau over 2 just to compensate for the difference in pi. And there's also like a tradition, but then you can argue like the U.S. is one of the only states, I guess the only country that actually uses standard measurement rather than metric. So that could account for some differences between translating between countries. Right. So if we just substitute for tau instead of pi, we get one revolution around the unit circle would come back to 1 when sine would still be 0. So right here, it actually does equal perfect unity between the different formulas. different fields of mathematics. Yeah, and here's a joke. Yeah. For those of you who know it, see what I'm saying. If you have a pizza with a radius of z and a depth of a, what is this volume? Okay. That's the next one. It's pizza. Y-E-Z-A. That's it.
Thank you. Any questions? Yeah.
So what is it about that theory that tau is better than pi that keeps the scientific world from seriously looking at it and possibly adopting it as a form of medicine?
What is this talking about?
Yeah.
Usually, I think it's usually just with the sense of tradition. Like, we learn from grade school, not grade school, wherever trigonometry started, that we always just learn pi. And tau is fairly recent. Like, they just started a couple years ago. I want to say 2005, around there. So it is a pretty new movement that they're just starting.
Any other question concerning this technical type of speech? I think next time you have to, you have to put your audience in consideration. The audience are first, the second, and the third.
I love
the
it. It reminds me
beginning
of
and
my
the
little
end.
brother. I love your speech.